that familiar feeling starts. That knot in your stomach.
Yeah, I know the one.
Because you know there's all this custom code hiding in there, right? Code that could break, cause massive headaches, and turn what should be a smooth upgrade into, well, a recovery mission.
Been there. Many of us have.
But what if there was a way, a strategic path, to make your custom ABAP extensions not just survive, but actually thrive through future SAP innovations, even if you're on-premise or in the private cloud?
That's exactly the vision behind this clean core idea. It's all about getting that upgrade stability, making sure your extensions stay compatible, stay agile.
Okay.
It's a pretty fundamental shift, really, moving away from that traditional ABAP approach, which, while it was incredibly powerful,
Oh, definitely.
it often created these really tangled dependencies, made smooth upgrades almost impossible sometimes.
Right. So for you, maybe you're working with SAP S4 on a cloud private edition or an on-prem system. This deep dive is hopefully your shortcut to understanding SAP's guidelines for ABAP Cloud API enablement.
Mm-hmm.
We want to show you how you can build extensions that actually stand the test of time, even if the public SAP APIs you need aren't quite there yet.
Yeah, our mission today is to sort of demystify how you can blend this new cloud-ready ABAP development with your existing classic ABAP stuff.
Okay.
We'll introduce you to this really powerful concept called wrappers. They act as a crucial bridge. We want to make sure you get the what and the how, but also the deeper strategic implications for your whole development landscape.
All right, let's set the stage then. Why are we even talking about a new way of doing extensions? What was so wrong with the classic way that kind of forced this evolution?
Well, the core issue with classic ABAP extensibility was, ironically, its sheer flexibility.
Right.
Developers could basically reach in and, modify almost any SAP object. Now, while that gave incredible power, it lacked clear, stable interfaces between SAP's own code and the custom extensions. This direct coupling, it just led to endless testing adaptation efforts every single SAP upgrade.
Yeah.
And in the public clouds, with its automated, frequent updates, that level of dependency, it just wasn't sustainable. It was basically a recipe for constant technical debt.
So the clean core idea really came about as the antidote to that, making sure extensions are strictly separated, only talking through these well-defined, stable interfaces. Makes total sense for public cloud. But what does this new model actually look like across the different S/4HANA editions?
Okay, so for SAP S/4HANA Cloud, we mainly talk about 3 ABAP-based options. First, there's key user extensibility.
Right, the low-code, no-code stuff.
Exactly. Think low-code, no-code tools for business experts.
Mm-hmm.
Good for simple UI tweaks, custom fields, basic custom objects.
Mm-hmm.
Then you got on-stack developer extensibility, which people often call embedded steampunk.
Ah, embedded steampunk, yeah.
This is for your pro ABP developers building extensions that need to be tightly coupled with S/4HANA data or transactions running right there on the S/4HANA stack.
Okay.
And finally, side-by-side extensibility, or just steampunk. This is more for loosely coupled apps, maybe partner SaaS solutions, often running on SAP BTP, the Business Technology Platform.
ATP, right.
And integrating with S/4HANA using remote APIs like OData services.
Got it. And the foundation for all of this, the common thread, is the ADP Cloud Development Model. What are its guiding principles? What does it really ask of developers?
Well, the ABP Cloud Development Model lays down a few non-negotiables. You must use only publicly released SAP APIs and extension points.
Okay, only release stuff.
You absolutely cannot modify SAP objects.
Yeah.
And you're expected to use ABP development tools for Eclipse, ADT, for all your development work.
ADT, yeah.
It's also very heavily centered around the ABP RESTful Application Programming Model, RAP.
RFE.
For building modern SAP Fiori apps and services. But the real kicker isn't just that these rules exist.
This is how they're enforced, right?
Exactly. That's where it gets really interesting. These are just suggestions on a slide somewhere.
No polite requests here.
No. The ABP Cloud Development rules are actually enforced by the ABAP compiler and runtime checks. So it's real enforcement. You've got a cloud-optimized ABAP language version, strict authorization checks, all designed to prevent any unauthorized tinkering with SAP objects.
Wow. So it's a complete mindset shift baked right into the tools. Stability by design.
Precisely.
Okay, so public cloud has its strict rules. But like you said, many organizations are in SAP S/4HANA Cloud Private Edition, or they're on-premise. That world's more complex, right? You've got existing code, processes. How do we apply this clean core thinking there? It's not like flipping a switch.
You're absolutely right. It's definitely more nuanced there. In private cloud and on-prem, you need a smart coexistence strategy. ABA Cloud development, that's clearly the default choice for anything new. That's what we call clean core level A.
Level A, the gold standard.
Right. But classic ABA development still has its place. And that's essential, really. For legacy code, you just can't transform immediately. Or maybe for new extensions in areas where ABA Cloud isn't fully there yet, maybe involving classic UIs like SAP UI.
So it's not either or, it's a strategic both and.
Exactly. It's about managing both worlds intelligently.
How do these two models actually interact then? Especially when you're trying to move towards that clean core, how do they, play nicely together?
Think of it like a walled garden, maybe. ABAP Cloud development stays strictly within its rules. It can only access its own objects, publicly released SAP objects, and this is key custom objects that have been specifically released for ABAP Cloud development.
Even if they were built in Classic.
Even if they were built in Classic ABAP, yes, as long as they're properly released.
Yeah.
Classic ABF, though, has broader access. It sees its own objects, released SAP objects, those older classic SAP interfaces, and all custom objects, no matter how they were built. This interplay, this interaction, is really central to what we're talking about today. How do you build secure, stable gates between these two environments?
Right. Which brings us perfectly to the heart of this deep dive.
Yeah.
The wrapper concept. Let's say you're doing ABAP Cloud development following all the rules, but you hit a roadblock. The function you really need is in SAP, but it's not exposed as a public API. What do you do then? Stuck.
Not stuck. This is precisely where wrappers come in. They're your elegant solution, your bridge over that gap.
Okay, how does it work?
So a custom wrapper object is built using classic ABAP. Its only job is to encapsulate or wrap the calls to that non-released SAP object you need access to. Once you've built this wrapper in classic ABAP, you then specifically release it for ABAP Cloud development.
So you make the wrapper itself behave like a released object.
Exactly. It effectively becomes your own custom interface, a released custom API that your ABAP Cloud code can consume safely and crucially stably.
Okay, so let me see if I've got this. You're essentially creating a controlled, documented entry point for interactions that would normally be off limits in pure ABA Cloud.
That's a great way to put it.
So this gives you that clear interface. It acts as a buffer, isolates the dependency. It mitigates the problem of missing released APIs, helps manage dependencies, makes future refactoring easier. And importantly, it focuses your testing effort right where the potential instability lies inside that wrapper.
Absolutely. It gives you control. It concentrates the risk.
Feels like taking back control, in a way.
It is. And it's important to mention, when you find you need functionality missing a released API, SAP does encourage you to use the customer influence channel to request it officially.
Right, ask for the proper API.
But, that takes time. In the meantime, the wrapper is your practical, robust solution. It's pragmatism meeting best practice.
Okay, that makes sense. So what kind of SAP objects are good candidates for wrapping? Can you just wrap anything, or are there specific types that work best?
Generally, you want to wrap objects that already have a clear API-like character. Things like BAPI function modules, those are usually pretty stable.
The classic BAPIs, yeah.
Externally released function modules, even non-released RAP business objects sometimes, and especially CDS views or underlying tables, though we generally prefer wrapping CDS views if possible. They tend to be more stable interfaces than tables.
CDS views over tables, okay.
Yeah. And the trick is you create these wrappers in a separate software component, usually one marked with the standard ABAP language version, keeping it distinct from your pure ABAPA cloud components. But you need to make sure the transport layers line up so deployment works smoothly.
Got it.
Yeah.
Separate component, standard ABAP, aligned transports. So as you're building these wrappers, some practical questions pop up immediately. Let's tackle a few. First, ABA dictionary artifacts. What if a specific SAP type or structure you need isn't available in the released APIs? How do you handle that inside the wrapper?
Good question. You've got a couple of options. Really depends on how those types are used. If the types are only needed internally by the wrapper function module or class, and the calling ABAP Cloud code doesn't need to know about them directly, you can just define them locally within your wrapper class using the type statement. Keep it encapsulated.
Keep it hidden inside.
Exactly. But if those types are needed to define, say, other custom dictionary artifacts in your ABAP Cloud code, then you'd basically recreate them as custom types directly in ABAP Cloud.
Rebuild them in the cloud world. Okay.
The principle is only expose what you absolutely have to. Keep everything else contained within the wrapper.
Makes sense. Now, authorizations. This sounds like it could get messy fast, dealing with non-released objects but trying to stay clean core. How do you make sure access is right without, poking holes in security?
Yeah, it can be tricky, but the core idea is always transparency and control. When your wrapped, non-released SAP API does its own authorization checks, it might use authorization objects that aren't released either.
Mm.
So the recommendation is, when you release your wrapper for ABP Cloud, provide corresponding SU22 default values. These are the standard authorization proposals.
Ah, the SU22 defaults.
Exactly.
Yeah.
And maybe even create specific SU22 variants for each ABA Cloud service that actually uses that wrapper.
Okay.
This makes the necessary authorizations totally transparent for your security admins. They can see what's needed and manage roles just like they would for any standard SAP object. You could even start with a role template, like SAP ABAP Developer 5, and add the necessary classic AV authorizations to it.
Okay, so make it visible and manageable through standard tools. Good. What about connecting outwards? Calling external services HTTP, SOP, RFC. How do wrappers fit in there, given the tighter rules in ABP Cloud?
Right now, the approach is basically to wrap the existing classic ADA classes for each specific use case. So you might wrap Cloud-Bound Provider HTTP or RFC or SOAP.
One wrapper per use case?
Pretty much.
Yeah.
However, it's definitely worth noting that this is an area SAP is actively improving. With SAP S4 HANA 2025, things are set to simplify quite a bit.
How so?
Well, direct communication targets are planned for HTTP and RFC right within ABAP Cloud itself. And SAP communication apparently won't require a wrapper at all.
Ah, okay. So the need for wrappers there might decrease over time.
Exactly. It shows SAP's commitment to expanding the set of released public APIs.
Good to know. Now, transactional consistency. Always a huge concern, right? Especially when you're mixing classic calls within a cloud context. What are the hard rules here? Can wrappers break transaction boundaries?
This is a really critical point. While wrappers let you call legacy APIs that might not perfectly follow ABAP Cloud rules, you have to be extremely careful with transactions.
Okay.
Statements like commit work and rollback work are absolutely never tolerated, even inside a wrapper. Using them will lead to runtime errors, full stop.
No commits or rollbacks inside the wrapper. Got it.
It's really the customer's responsibility to ensure the overall transactional integrity and correct functionality. And tools like the checkpoint group, CCSTMT, can help. They can log violations during testing so you can find them.
So use the tools to check.
Definitely. The hard rule is keep your transaction control outside the wrapper's immediate execution. Let the calling ABAP Cloud logic handle the commit or rollback for the entire unit of work.
Right, makes sense. Keep the wrapper focused on just the non-released call. And what about tapping into powerful SAP ANA features? Things like CDS table functions or ANCP, which I know have some limitations, like maybe only read-only scope in pure ABAP Cloud. Can wrappers help unlock more potential there?
Yes, they absolutely can. You can develop those advanced objects like a CDS table function or a class that implements an AMDT method using classic ABA where you might have fewer restrictions.
Develop it in Classic first.
Right. And then the trick is you release a CDS view entity that uses that table function, or you release the AMDP implementing class itself, making it available for ABE Cloud development.
Ah, so you expose the result or the capability as a cloud-ready interface.
Exactly. It effectively extends the capabilities available to your cloud-ready extensions, letting you leverage that underlying ADA power through a controlled released interface.
Clever. Okay, so we have all these different extension types: Classic Code, ABA Cloud Code, wrappers bridging the gap. How on earth do you maintain quality and ensure everyone's following the rules across this potentially complex landscape?
Sounds like a job for the ABAP Test Cockpit, right? ATC is this central quality gate.
Precisely. ATC is really the undisputed tool of choice here. It governs static quality assurance for both ABAP Cloud and Classic ABA per development, and it's perfectly aligned with this clean core level concept we mentioned earlier.
Okay.
The strong recommendation is to set up a central ATC system. Could be on SAP BTP, could be on-premise to monitor your entire development landscape. It gives you that single source of truth for code quality and compliance.
Right, so you mentioned clean core levels. Can you break that down for us? What are these levels, and how does ATC use them to guide developers?
Sure. The clean core level concept basically classifies your custom code based on how well it adheres to the cloud readiness rules. It gives you clear guidance.
Like a grading system. Kind of, yeah. You have. Level A, that's your gold standard.
Yeah.
Pure ABAP cloud development, strictly following all the rules. No compromises. ATC checks enforce this strictly.
Level A, pure cloud. Got it.
Level B, classic APIs. These are specific APIs SAP has nominated as acceptable, maybe even recommended, for classic ABAP development. They're often listed in a GitHub file. If you use one, ATC will show an info message. It's not an error, just a heads up, maybe guiding you to a more modern alternative if one exists. Think of something like CLGIL, VG, or I might fall here.
Okay, level B. Okay, ish classic APIs, just an info.
Level C, SAP internal objects. This is the gray area. These are non-publicly released SAP objects that SAP hasn't explicitly classified. Using these results in an ATC warning.
Warning, okay.
And this is exactly where wrappers or the recommended best practice wrap the level C object to control the dependency.
Right, wrap your level C warning.
Level D, not recommended objects. These are objects explicitly assessed by SAP experts as unsuitable, maybe unstable, or problematic. Using these gets flagged by ATC with an error.
A hard error. Stop.
Yes, an error you must fix. Think of notorious function modules like RFC RAID table. ATC will block usage, pushing you hard to find a released alternative, a classic API, level B, or just refactor your approach completely.
Level D. Big red flag. Must fix.
Okay, that breakdown A, B, C, D is really clear. So what are some of the key types of ATC checks people should be running to enforce this? I know there are many, but what's the core focus?
Yeah, the core focus is really on catching potential upgrade risks and non-compliance early. You'll definitely want checks like system usage of FAPIS, that's the one flagging usage of classic SAP objects based on those levels.
Okay.
Then there's site-critical statements, crucial for catching statements that could threaten security or stability. You absolutely need site search custom modifications to find any direct modifications of SAP objects, which is a huge no-no for clean core.
Right, no mods.
And something like CISR and SCTEC for general security vulnerability is always a good idea. There's a comprehensive list available. We can link to it. But the key is that these checks become your automated guardrails, enforcing the clean core strategy. Automated guardrails. I like that. But let's be practical. Sometimes maybe you absolutely have to use an SAP internal object, a level C situation. How do you handle those exceptions within ATC without just opening the floodgates or making a mess of your governance?
That's where wrappers really prove their value again. For those unavoidable level C findings, you can use ATC exemptions.
Okay, exemptions are possible.
But the best practice, especially if it's an internal API you use frequently, is to create that wrapper around the level C object.
Wrap it first?
Yes, because then you only have one usage of that internal object inside the wrapper itself, which means you only need one ATC exemption for that single finding in the wrapper.
Instead of exemptions scattered everywhere.
Exactly. It massively streamlines governance. Your exceptions become manageable, documented, auditable, concentrated in one place, rather than being spread all through your custom code.
That's much cleaner. Looking ahead then, how can developers get a better handle on the potential upgrade stability of their code, especially when it does rely on some of those SAP internal objects, even if wrapped? Anticipating change feels key.
SAP is definitely working on improving visibility here. The plan is to offer a change log specifically for SAP objects.
A change log? Interesting.
Yeah, it would list incompatible changes introduced in new SAP releases for things like function modules, classes, CDS views. And crucially, there's also a planned ATC check that will analyze your custom code against this change log.
Wow, okay.
So the idea is you could run this check before an upgrade and identify potential issues proactively based on documented changes in the SAP objects your code uses.
That'd be huge. Moving from reactive fixes after an upgrade breaks something to proactive analysis beforehand.
Exactly. It's about giving you foresight and time to adapt before the upgrade even happens.
That connects nicely to the bigger picture. Many organizations aren't starting fresh. They're migrating existing classic ABAP code, sometimes decades of it. What's the strategic roadmap for dealing with all that legacy code while trying to move towards a cleaner core? How do you tame that beast?
Taming the beast is a good way to put it. The main goal has to be minimize and rigorously control the amount of classic ABI custom code you carry forward. Ideally, you do as much cleanup as possible before any system conversion.
Clean up first.
Yes. Then, for what remains, there are essentially 4 key strategic options, almost like a decision tree you work through.
Okay, what are they?
First, retire. Find and remove custom code that's just not used anymore. Maybe standard SAP covers it now. Maybe it was a clone that's redundant. Tools like the Custom Code Migration app are great for identifying candidates here. Just get rid of the dead weight.
Option 1, retire the unused. Makes sense.
Second, renovate and innovate side by side. If you have loosely coupled extensions, the strong recommendation is move them off the S/4HANA stack entirely onto SAP BTP. Leverage BTP services, keep the core clean.
Option 2, move it to BTP.
Third, renovate and innovate on stack. For extensions that really need to be tightly coupled, or maybe legacy modifications that are still absolutely necessary, you re-implement them. But you do it using the ABAP Cloud development model.
Rebuild it using ABAP Cloud rules.
Exactly. Replace those non-released SAP object calls with proper released APIs, use released extension points, bring it up to modern standards, make it level A if possible.
Option 3, rebuild it clean on stack.
And fourth, adapt.
Yeah.
If the other options just aren't feasible right now, maybe it's too complex, too costly to rebuild immediately, then you must at least adapt the existing code. Use the simplification database, run ATC, apply quick fixes.
Adapt the existing code. What does that mean practically?
It means, at a minimum, getting rid of the worst offenders. Eliminate level D objects, no modifications, no direct writes to SAP tables, no using those explicitly not recommended APIs. And try hard to minimize level C usage, like direct reads from SAP tables or calls to internal APIs, ideally by wrapping them, like we discussed.
Option 4, adapt, fix the worst, wrap the rest.
Pretty much. It's about damage control and setting yourself up for future renovation.
So listening to all this, it's really clear this isn't a one-time project, is it? It's more like a continuous journey, a strategic transformation of your entire code base over time.
Exactly right. It's an ongoing process. It's about strategically evolving your code. You can even take individual development objects one by one and change their ABAP language version setting to ABA for cloud development.
Change the language version object by object.
Yes, and then use ATC check variants like ABAP Cloud Readiness to guide you through the necessary fixes for that specific object. The aim is always to gradually move everything towards that cloud-ready, upgrade-stable state. It's about building resilience for the long term, piece by piece.
Wow. Okay, what an incredibly insightful deep dive. We've really unpacked the strategic world of ABAP Cloud API enablement and this whole clean core journey. It's clear how SAP is guiding developers towards, well, a future of hopefully much smoother upgrades and true cloud readiness, even if you're in a complex private cloud or on-premise setup. From understanding why this new model exists to strategically using those wrappers as a vital bridge for missing APIs, and then leveraging powerful tools like ATC to actually govern the transformation, it really highlights that thoughtful planning and maybe a new way of thinking are crucial.
Indeed. And the shift towards ABAP Cloud development, when it's supported by a really clear understanding of classic APIs, those clean core levels A, B, C, D, it isn't just about adopting some new tech buzzword.
No,
It's about fundamentally changing how you approach custom development within the SAP ecosystem. It's about ensuring long-term stability, agility, and honestly, significantly reducing that future maintenance headache.
So thinking about everything we covered, what's maybe the big takeaway for you listening? Perhaps it's this idea: your custom extensions, which might have been a major source of upgrade pain in the past,
Oh, yeah.
can now become resilient, future-proof assets ready for whatever SAP innovation comes next. The journey to a clean core is definitely an investment, no doubt, but it seems like one that promises pretty significant returns in lower effort and a faster path to a modern cloud-ready landscape.
And remember, as you're navigating this, that ability to selectively build wrappers for the non-released bits gives you control where you need it. And the ABA Test Cockpit, ATC, acts as your essential governance safeguard throughout the process.
Right.
It really empowers you to take a strategic approach to extensibility, not just a purely technical one.
An empowered and strategic approach. Love that. Okay, absolutely fantastic. Until next time, keep exploring, keep innovating, and keep that core brilliantly clean.